Scientists found the lid, keeping the Yellowstone supervolcano from erupting. Scientists in the United States have blown the lid off the Yellowstone supervolcano's mysterious underground reservoir of magma. A team of geologists and earth scientists now claims to have finally found the deep magma cap that keeps the volcanic system's high pressures and temperatures locked up underground. The lid to this volatile Pandora's box exists between 3.5 and 4 kilometer, 2.2 and 2.5 miles below the northeastern part of the Yellowstone caldera, according to new models. And it seems to be regularly letting out little belches of gas, holding an explosion at bay. Scientists liken the effect to steady breathing, as if the volcano was in a peaceful slumber. But if enough air was restricted in the supervolcano's throat, then at some point an eruptive snore could bellow forth. Thankfully, the magma cap works sort of like a CPAP machine, keeping internal pressures relatively stable, allowing the supervolcano to sleep somewhat soundly. For decades, we've known there's magma beneath Yellowstone, but the exact depth and structure of its upper boundary has been a big question, explains earth scientist Brandon Schmandt from Rice University. What we've found is that this reservoir hasn't shut down. It's been sitting there for a couple million years, but it's still dynamic. Today, abundant evidence suggests that there is a magma reservoir sitting in Earth's crust, just beneath the northeastern part of the Yellowstone caldera. How deep that reservoir lies and how much magma it holds, however, are still up for debate, making it challenging to predict when the supervolcano will next blow its top. Schmandt's co-lead author Chenglong Duan developed a new method to image Earth's crust in the Yellowstone region. The technique relies on sending seismic waves, akin to tiny earthquakes, into the ground from a vibrating truck to see how they travel through rock layers. As these waves reflect back to the surface, they are collected by hundreds of seismometers. Collaborating with geophysicist Jamie Farrell from the University of Utah, the team developed an algorithm that reads through all this noisy data to create a model of layers in Earth's crust. It has now provided what Duan says are the first super clear images of the top of the magma reservoir beneath Yellowstone caldera. About 8 kilometers below the surface, the probing seismic waves encountered a sudden boundary. They no longer appeared as though they were flowing through rock. Instead, their sluggish movement suggested they were moving through a muddy mixture of supercritical fluid and magma between 3 and 8 kilometers deep. The good news is that recent evidence suggests the risk of a Yellowstone super eruption is decreasing, which means we probably aren't due for a landscape-destroying tantrum anytime soon. Geysers may keep exploding in front of tourists, and swarms of small earthquakes may shake the region for periods of time, but studies generally suggest the volcano is in a state of repose.